Well, good morning and welcome to Whitmix's webinar, What 3D Printer is Right for Me? Today's webinar is presented by Sherry Weatherby. My name is Bernie Jarislow. I'm the marketing manager for Whitmix and I'll be facilitating today's webinar. So I want to begin with a few housekeeping items. First, in the upper right-hand corner of your screen, you should see a questions box, and you're welcome to type any questions you'd like throughout the presentation, but Sherry won't be answering those until the end of the webinar. But we will address all the questions. Next, if you're a CDT, this webinar is approved for 1 hour of CE credit toward your recertification. You'll receive an email within 1 to 2 days that will explain how to obtain your credit. I will tell you now, it does include a very simple test, but we just want to make sure you're listening. And then lastly, this webinar is being recorded. Within 48 hours, it'll be up on the Whitmix website in the webinar section. This morning, I have the pleasure of introducing Sherry Weatherby. Sherry is a territory sales manager and prides herself as being a customer advocate. She focuses on sales efforts revolving around all things digital, covering the southern half of the United States for Whitmix. Sherry has over 25 years in the industry, getting her start at the age of 14, making dentures. Aside from being a technician, she's added retail, direct, and manufacturing sales to her resume. You can often spot Sherry on many different social media platforms, sharing her passion for our industry. So today, Sherry will be speaking on choosing the right 3D printer for your lab. And I think that's all I've got, Sherry. So if you're ready, let's talk about 3D printers.
Great, thank you, Bernie. Good morning, everyone. So thank you for joining me, and let's go ahead and get started. Maybe, maybe not. There we go. Okay, so let's talk about the different types of 3D printing technology. For starters, on the top left, you can see that there's the FDM, and that's basically like 3D printing Valplast. The SLM is technology that is used for printing metal. Then we have SLA, which is very similar to the Formlabs printer. And then we have DLP, which we have a variety of DLP printers out on the market. So let's talk about stereolithography technology. So this is a process of solidifying a photopolymer resin layer by layer that is activated by a UV light engine. So we start with the laser SLA. That's kind of the oldest form of technology that's been out for quite some time. DLP is a little more modern version of stereolithography printing. And then we also have MSLA, which is an LCD mask form of stereolithography, which is the newest form of printing. So we're going to start with going over the different types of printers on the market. Again, SLA, which is a laser that traces the object on the build plate. So this would be the Formlabs printer. This is a hobbyist printer that was actually brought into our industry. I would have to say this is probably by far the most popular printer that's out there right now. The XY accuracy of this is 140 micron, which to be frank is great for anything removable. If you're doing custom trays, ortho models, but anything crown and bridge, that really is not accurate enough for crown and bridge models, especially when you have a removable die. It does have a good size build plate at 145 by 145. It is in fact a closed system. However, you can run it in open mode. And when you run this printer in open mode, you're disabling the heater and the wiper, which is actually an important function with a printer when you are using different resins. So with that being said, for this printer to work at its capacity, you would be really want to focus on using just the resins that Formlabs provides for their printer. The next one is the frozen shuffle. Now this is the LCD mask technology. On the left, you can kind of see how that technology works. And this printer actually is fairly accurate at 47 micron. The build plate is a decent size at 120 by 68, and it is an open materials printer. However, with this printer, you kind of have to think about tech support. It is from overseas. So one of the things that I would encourage you to do when investigating a printer like this one, just make sure that you have good tech support lined up for this printer. One of the things that you really could do is just call the number for the company and ask to speak to someone in tech support and see what that experience is like. The EnvisionTEC MicroPlus XL, you can get this printer for around $10,000. On their website, it's a little confusing. Their XY accuracy, they have the X-axis listed at 82 micron and the Y-axis listed as 105 micron. Not really sure what that equates to because most companies actually just have a finite number that they specify as the accuracy. This printer is closed, so you are stuck using the resins that EnvisionTEC provides. So you cannot choose any other resin on the market. So again, this is the DLP technology, which is direct light printing, which is the more modern version of the technology we have right now. Another DLP printer is the Kulzer Cara printer, and the price point of this, I actually priced this out with No Dental. They sell it for $14,330. This is actually a pretty accurate printer at 54 microns. The build plate on it's a little bit small at 103 by 58, and this printer is also a closed system. So again, you're going to want to explore what their options are for resins and make sure that this printer can cover all the different things that you want to print within your laboratory before making that decision to move forward with this printer. Another DLP printer is the Nextent 5100. Everyone has been waiting for this baby to come out on the market. And I actually got to take a look at it at the meeting back in September in Arizona for the digital denture meeting. So the price point of this printer is $10,000. That does not include the base that's on wheels. That is actually a separate purchase. Their UV print box is priced at $1,800. You also have to get, it's kind of like a hot dog roller, if you will, the LC 3D mixer. So the resin that they have, it kind of separates and you have to shake it for quite some time to actually get the right consistency with the resin so that you don't have a failed print. So you do have to have that additional piece of equipment. And then they also have a mandatory training where you're paying for a technician to come in and do training at your laboratory, which is an additional $1,450. So this printer is actually pretty accurate. It's 65 micron, and it also has a pretty good build plate size at 125 by 70. Next up, we have the Moonray, the S100, and this is also direct light printing technology. So the price point of this is just under $4,000. The accuracy of this particular printer is 100 micron. Now they do have another one that has a 75 micron accuracy, and the build plate on that one is actually even smaller. So for the 100 micron Moonray unit, that one has a build plate size of 125 by 80. This is also an open materials printer. And it's available through several different resellers. Next up, we have this big boy, so the Carbon printer. This is the M2, and this is actually a lease option. You do not purchase this printer. This printer has a $50,000 a year price tag for 3 years, and then you're also going to pay a $10,000 fee for the install. This printer is actually pretty awesome. It has continuous printing. Some of the DLP printers, when it's printing, that build plate lowers down into the vat of resin, and each layer is printed. And in between each layer, the UV light flashes, the build plate actually lifts up and then goes back down for the next layer. Whereas with this technology that Carbon has, when that build plate lowers down into the vat of resin, it has the continuous printing, so it doesn't actually raise up and go back down. So this printer is actually going to be a little bit faster, well, quite a bit faster than a lot of the other DLP printers on the market because of that technology. I do want to also go back to this. So the carbon printer, it is actually a closed system. So again, you know, you want to look at the resins that they have available with their printer, make sure that all the indications are covered that you want to print within your laboratory. Then we also have the Rapid Shape D20. This printer is actually not advertised as far as price goes. We reached out to try to get that information for you guys, but was not successful. This printer actually is very accurate at 34 micron, and it actually has a really good build plate size as well, which is 130 by 75. This printer is also an open materials printer, so you have options to plug in different resins to this printer. Then we have the MeCraft. I really hadn't heard a whole lot about this one until I started Googling it. So this is actually made overseas, and it's actually pretty accurate at 65 micron. It has a decent build plate size at 125 by 70. The price point of it is $13,500, and it also is an open materials printer. Again, with that being said, with this printer coming from overseas, I really haven't been able to find any resellers of this printer here in the United States. So again, when exploring those options, you need to make sure that you have some sort of local tech support so that if your printer goes down, you have someone that you can call and get that help. Roland also has launched a printer, so the DWP-80S, priced just under $16,000. This one has an 80 by 80 build plate size, so it's fairly small. They do not have the accuracy of this printer listed anywhere online, so I wasn't able to get that plugged in for you. But I can tell you that it is a closed system, and they advertise this specifically for custom trays, base plates, and frameworks, nothing else revolving around crown and bridge. So again, this printer here has somewhat of a narrow focus for our market. And then we have, of course, my beloved Asiga Max. This is a DLP printer as well. It is an open materials printer. It's extremely accurate at 62 micron. The build plate size on this printer is 119 by 67 by 75. Now, the reason why I put the Z-axis height on here at 75 micron is because with the Asiga, you get software that is called Composer, and it is proprietary to Asiga. And within this software, you can actually create a stack. So just kind of imagine a three-tiered parking garage, if you will, with cars parked on each level. So within the software, you're going to be able to design supports, put down a honeycomb waffle layer, then you're going to nest your models on that layer there, go ahead and create another stack of supports, another honeycomb layer, and then nest more models on that top tier. So you do, again, you have that 75 millimeters in height to work with to create that stack. Now, ideally, you don't want to do that stack throughout the day. In order to be a lean manufacturer, it's ideal for you to print one row at a time throughout the day, pop your models off, put them in your clean alcohol bath and your dirty alcohol bath, do your post-processing, and go ahead and start your next print run. That way, you're just keeping the productivity moving, doing small batch processing, and then save that stack feature for the end of the day. So let's say at the end of the day, you have 9 models left that need to be printed. Go ahead and create that stack, nest your models, hit start, walk away, go home and live life while your printer is back at the lab printing for you. So obviously, you know, you're also using more resin by creating those stacks. So again, that's why we really encourage you to utilize that feature at the end of the day. Now, I do have one of my favorite technicians sitting here with me, Corey Lambertson. There is a feature with this printer that I actually would like for him to talk about, the internal radiometer, something that kind of sets this printer apart from other DLP printers on the market. So, Corey?
Yeah, so thank you for chiming in on that, Sherry. So the internal radiometer, all of the Asiga printers have an internal radiometer. And what this radiometer actually does is it takes an instantaneous reading of what the LED output is of the projector itself. So each projector is going to have a different intensity, and the intensity over time, it can fade and dissipate. As the years goes on and you're using this machine, the intensity is going to become lower. And so and this is across the board for all 3D printers, by the way, the intensity will lower on all of them. So this feature of having this internal radiometer, it's actually going to pick up what that instant reading is, and it's going to automatically adjust the exposure time needed to cure the resin for that layer. And so what this does is this helps the end user in the long run to have the same output of prints, the same quality of prints, and it's going to reduce the amount of failures as the life of the printer continues, because it's going to automatically adjust that exposure time for each print job. Other printers, what will happen is the life continues with the printer, you're going to start to receive failed prints where it's being underexposed. The LED light is decreasing, but the software on the other printers are not going to automatically compensate and increase that exposure time. So you're going to start to receive failed prints, and then you have to send your printer in for repair. The Asiga printers, you're not going to have to do that because they're actually going to automatically adjust the exposure time needed, which is an incredible feature that Asiga came up with.
Great, thank you so much for that, Corey. So I'm not even going to pretend like I'm the genius that put this slide together. I am going to touch a little bit on why I have this slide here. So I focused on how some of these printers are closed, how some of them are open. And the cool thing about having an open materials printer is that you have so many options on resins on the market, where you could plug in Procedure, DTax, Keystone. They've come out with a great line of resins. You can plug in Nextent. You can plug in Whitmix. You can plug in your resin of choice with an open materials printer. And so I'm going to actually have Corey chime in, because he is kind of the genius that put this together. He's very passionate about 3D printing, and he can explain exactly how it is that we can plug in a resin outside of the system into an open materials printer. Go ahead, Corey.
Yeah, so with every resin that's available on the market, it has a certain cure curve to it. It's unique to each formula for each resin that is manufactured. And so what goes into this is there's a certain amount of exposure time needed to cure a certain layer thickness. So the exposure time is calculated from a dosage of light. And so how this was actually measured, we're going to take a printer, any given printer that's open source, and we actually here at Whitmix, we have these external radiometers that we can record or find out what that intensity is. And so we'll record down that number, and let's say it's 10 milliwatts per centimeter squared. Well, what we're going to do is we're going to look at our cure curve, and we're going to say, we want to cure a layer that is 0.1 millimeters thick. And if you look on the left side of that chart there, we can see 0.1 millimeters. And then if we were to look down at the bottom, that's the dosage of light needed. So it's about 50, a rating of 50. So we would take the 10 milliwatts per centimeter squared, divide it into that dosage of light of 50, and that's going to give us our exposure time. So we'd actually cure that layer, and it would take 5 seconds to cure that layer of exposure. And so the right-hand side kind of just goes over the formulas of it. So we have a UV light engine that's measured in the milliwatts per centimeter squared. And if we take the milliwatts per centimeter squared and times it into a value of time, which would be the exposure time, that gives us the dosage of light. So the dosage of light links directly to the thickness of a resin being cured. And how we get the exposure time, we take that desired layer thickness and divide it into the milliwatts per centimeter squared. So it's a unique formula on how we're able to formulate or create material files for external printers. But it all came from being able to use the Asiga 3D printer and how open that is. We came up with all this information from the Asiga 3D printers. So they're well thought out, and they're just phenomenal. But we use that information moving forward for other printers as well.
So again, if you have an open materials printer, just to give you an example, I had a customer call and say, hey, I've been using your ivory model resin and I'm going to use the white. Can I use the same material file? Well, the answer to that is no. Even though they're both model resins, very similar formulas, they are different colors. And basically what happens is, those different colors will need that UV light to flash to cure each layer for X amount of seconds. So even though it's the same material, again, with that different color, the UV light will affect it differently and need to be cured for a specific amount of time in between each layer. All right, moving on. So we're going to talk about wavelengths. So you'll see some printers out there are 385 nanometers. Some of them are 405. So you kind of have to look at the different options for resins on the market as well when you're deciding on a printer. Some printers you can actually get in either 385 or 405. And then there are others that are specifically sold just as a 385 or just as a 405. One of the reasons I particularly lean more towards the 385 is because when you are curing or printing a clear resin, it actually will come out clear and not have that yellowish tint. Whereas on a 405, because it is using less energy, the clear resin actually tends to have that yellowish tint, which really isn't a huge deal for surgical guides. But as we start to bring out more resins out that are FDA cleared and have that 510K approval, for a patient to take something home that's been 3D printed, I'm pretty sure they're not going to want something that has that yellowish tint to it. They're going to want something that's a little bit more clear and clean looking. So again, let's just kind of go over the differences. A 385 has an ultraviolet light that can be harmful to tissue. Again, it's using more energy, which helps prevent the yellowing of clear resins, and it also has controllable light penetration. So the 405, it has visible light, it's easy on the eyes, it uses less energy. Again, that tends to make the clear resins have that yellowish tint, and the light penetration with a 405 nanometer light processor is not controllable. All right, so this is kind of my favorite slide because this is kind of a system that I put together that I encourage every lab that I talk to, get test prints from every single manufacturer that you are considering. What I would encourage you to do is, if you're planning on printing models, get a master file together of an iOS scan to send to every single manufacturer so you can get an apples to apples comparison for quality and accuracy. Now, it's also important that when you send that file, that you do not model build it. If you don't have, if you're a 3Shape lab as an example, if you don't have that DME file, then if it has a removable die, it's not going to fit properly. So just make sure that you send a raw scan, send the same scan to every printer manufacturer that you're considering. And there are a list of questions that you really want to ask. So you want to ask, what is the pixel accuracy of this printer? Obviously, the more accurate, the better. What micron layer thickness was my test print printed at? With a model, typically you want that printed at a 50 micron thickness. However, if you are printing, let's say, an ortho model, you can actually print that at a 100 micron layer thickness and cut that print time in half. How long did it take to print? Again, that kind of ties into the micron layer thickness. But just to give you an example, even though technologies are similar, the print time can definitely vary. Just within the Asiga line, as an example, we have the Asiga Max, and then we have the big one, the Pro 275. And what would take you 1 hour to print on the Asiga Max is going to take you an hour and 40 to hour and 45 minutes to print on the Pro 275. Now, if we take that same file and send it over to Carbon, it's actually going to print even faster because they have that continuous printing technology. So it's important for you to ask how long it took to print. Even as another example, what would take you 1 hour to print on the Asiga Max, is going to take you a good 3.5 hours to print on a SLA printer, such as the Formlabs printer. So you have to look at your production and see, you know, how many models a day am I going to print, or how many castables am I going to print? How many custom trays a day am I going to print? How many dentures or try-ins am I going to print? So you really have to take that into consideration when making a purchase. So do you want to buy, you know, a $3,000 or $4,000 printer that's going to take 3 hours and 45 minutes, or do you want to spend $10,000 to $14,000 on a printer that's going to be a lot faster to keep your production moving? Is this an open materials printer? If it's closed, you want to know what resins they have. How much are those resins? What consumables are tied to this printer, and how much are they? As an example, with the Nextent and the Calzer printer, those trays are actually right around $1,000 a pop. So you want to make sure you ask these questions so that you can see what those future expenses are going to be outside of the cost of the capital equipment. And then you also want to know if there's any support fees, annual renewals on the software. Just make sure you ask all of those questions. And then again, going back and focusing on tech support. Call their tech support team, ask questions, see how easy it is to get someone on the phone or someone to respond back to you, because that's another key factor. So when doing the test prints, again, just make sure you're sending the same file to everyone, so you have that apples to apples comparison. And I would even go as far as asking for a demo of the software online through TeamViewer. Make sure that that software is user-friendly and intuitive before making that decision to move forward. Once you get those test prints back, there's actually software out there that will allow you to check the accuracy of the models, as an example. So Corey, I'm going to have you chime in here because this is kind of your specialty with Reshaper. If you just want to kind of explain how this works.
Yeah, so what we did is, or whenever we're testing a new resin or validating an existing resin or a new lot of production, what we do is we use a software to check the accuracy. So we'll take a printed model, we'll scan the printed model, and then we will align it to the STL file of that. And then we check for deviation, or we check to see if it has any sort of outlying areas that need to be adjusted. Maybe we need to adjust our formula to change the amount of either shrinkage or growth, or maybe we need to add in some shrinkage or growth characteristics in the material file for the printers themselves. So we use a software here with Mix called 3D Reshaper, and you can actually do something on your own as well if you want. Just get a hold of me here at Whitmix, and I can show you how you can use your own 3Shape scanner to scan and compare models as well. But essentially what we do is we'll overlay these two objects. So we'll take the scan of the printed model and the actual STL file of the model, and we're going to overlay those together, and we're going to see where it deviates. And we can see we have 3 different prints here. These are actually from 3 different printers. The one on the left is from an Asiga Pro 2. Within 75 microns, we had a 92.3% match, which is phenomenal. The other 2 printers were actually printers that were $100,000 plus and similar technology. And the printer in the middle, they actually had a 79.9% match, and the printer on the right had an 88.7% match. So you can see, you know, that each printer is going to make a difference, and it also even makes a difference for what resin you're using as well. But you know, this is how we compare and how we test to validate that our objects that we're printing are accurate enough for the application we're testing it for. And yeah, if you have any questions at all, feel free to contact me, and I can show you how you can do this on your own. Also, if you look at the curvature of the line that's on the right-hand side that shows where the accuracy is concentrated at, you can see where all of these actually peak directly in the center, which is right at 0. So 0 microns of deviation or difference. It's peaking right at that point, which is phenomenal. That's what we want to look for. But yeah, so it takes some time to get used to it, but we do this pretty regular for all of our resins.
Awesome. Thank you, Corey. All right. So this is one of my passion topics. 3D printing dentures. So this technology is moving so fast. And as a trained denture technician, I am ecstatic to see this technology actually infiltrate the removable lab. You know, even as a sales rep walking into a lab and seeing a lab tech sit there with his white apron on and 10 pounds of pink wax build up on his belly from sitting at the bench, you know, that ideal image that you have in your head of a denture tech is actually going to start shifting as our technology continues to improve and materials also begin to improve. So this, the pictures that you actually see here on the screen, I had a lab send me some files to do a test print, and this was actually printed with the Dentka resin. So on the left, that's what it looked like coming off the printer, and on the right, that's what it looked like once the teeth were bonded into the denture base. So let's talk a little bit about the different systems that are actually FDA cleared and 510K approved. You know, going back even 6 months ago, I think a lot of people had this idea that they could buy any open materials printer, grab Nextent resin or any other resin out there that comes along for dentures and plug that into their existing printer. In fact, you cannot do that according to the FDA. So an actual 510K approved system includes the printer, the resin, and the high intensity light curing unit. So you actually have to follow all three of those pieces that have been approved and 510K cleared as a system. So right now there are two manufacturers of the denture-based resin. Vertex Dental is one, and if you go and look at the FDA site, you can see the different systems that are actually approved with this resin. So Vertex resin, which is more commonly known, I guess, in our industry as the Nextent resin, can be plugged into the EnvisionTech printer. It can also be plugged into Rapid Shape. However, we did confirm yesterday that they are not selling the Rapid Shape printer in the United States for the application of digital dentures. The MeCraft printer has been approved. Of course, we have the Nextent printer. The Roland printer was on the list, and Moonray was also on that list. So again, if you want to do digital dentures and you have one of these printers that I just mentioned, you have to use the Vertex Dental resin, whether it's private labeled under Nextent or if they bring it out under a different label later. So then we move on to the Dentka resin. So when you look up the Dentka with the FDA, this resin is actually private labeled and has been approved for the carbon printer, the Kulzer Kara printer, and with the Asiga printer, that's actually in the process of getting validated. So that will actually be available more towards Chicago of 2019. So again, just keep in mind if you want to follow that dotted line and be on the right path, you need to make sure that you stay within an approved system, including the printer, the resin, and the high intensity light curing unit for bonding the teeth into that denture base. So with that being said, I am apparently a very fast talker, and we are at the end of my presentation. I do want to encourage any of you that have any questions, feel free to reach out to me. All of my contact information is listed, and you can connect with me on any of these social media platforms. I do post quite a bit about stuff within our technology, and then of course a little bit here and there about my four little crazies that I also take care of. So thank you very much. And Bernie, if you want to go over the questions.
Absolutely. Great job. Thank you, Sherry. All right. The first question I see here, this is not really a question, 128. I don't quite know what that means. But next is diamond size pixel instead of a square, hence the difference, I assume, between X and Y measurements.
Perhaps he's chiming in on the statement on the EnvisionTech printer. Do you think that might be it, Corey?
Well, yeah, I'm guessing that's what he's referring to. But so it's, yeah, I'd be curious to see why they're projecting a diamond-sized pixel instead of square. I mean, obviously the engineers found a reason for it, so I'd be curious to see what it was.
Yeah, so Chris, if you would like to reach out to us and explain that, that would be very helpful and appreciative.
The next question is, does the user have to figure this out for each print job? For example, if we design a splint at 2 millimeters, it will need a longer time than a splint at 1 millimeter. Do we need to change this each time we change the thickness of print?
No, so if you're printing a splint that has a 2 millimeter wall thickness and a splint that has a 1 millimeter wall thickness, you're fine still using either 50 or 100 micron layer thicknesses. I'm guessing that's what the question was trying to refer to, is like, what layer thickness do I use for each print job? You know, it really comes down to the surface quality you want. So, for example, the denture bases, when we're finishing those down and polishing, I'd rather print it in a 50 micron layer versus a 100 micron layer because I'm going to have to spend less time polishing it. You could think the same way for a splint as well. It really comes down to where you want to spend your time at. You know, you can spend more time printing and less time finishing, or you can spend more time finishing and less time printing for those type of applications. But crown and bridge, you're going to want to stick strictly at 50 micron thicknesses or less.
Okay. The next question is examples of other type of FDA resins other than the denture base.
So surgical guides are just a class 1 medical device, so that you don't have to be any part of any system. But if it's a class 2 medical device, then it's going to need to be part of that 510K system, where you're going to have, you know, you need to have a resin that is validated with a printer that is also validated with a curing unit. Something that you'll see in the future will be like the splint resins. We're coming out with one that is 510K certified or approved, and that will be certified with the Asiga 3D printer. And you do have to follow the curing instructions as well. There are others out there, but you have to do the research. And when you do the research, make sure that if it is a resin that has to follow a 510K process, make sure you're following that process to a T, or else you won't be 510K approved.
Okay. Let's see. Can we get a copy of this presentation? Thanks for making this topic more simple to make a decision. And we thank you for that comment. And the answer to that is very simple. As of tomorrow or the day after, latest the day after tomorrow, this presentation will be up on the WhipMix webinar website. So just go up to whipmix.com and go to webinars, and you'll see the webinar there, so you'll be able to watch it as often as you'd like. The next one is class 1 versus class 2 definitions.
So I would, you know, of course, always refer to the FDA website because that is a constant evolving topic. Class 1 medical device, I'm pretty sure, if last time I checked, it was a device that could be contacted into the person that's less than 30 minutes, and then class 2 would be more of a long-term device. So with that, you know, you're going to have different requirements of what is needed. Both devices, class 1 and class 2, you need to follow the strict post-processing protocol. And if there's any limitations for what printer that they are certified with, you need to follow those.
Okay. The next question, we've got one up here. What light curing unit is going to be required for use with the Denka resins on an Asiga printer?
So Justin, to answer your question on that, we have narrowed it down to a few. We have sent the Asiga printers off to Denka to finish up the validation process. And once they are done with that validation process, we will have then settled on the light curing unit, the high intensity light curing unit that will be used in that system for bonding the teeth to the denture bases. So right now, I don't have an answer for you on that just yet.
Okay. The next question is, please give examples of other type of FDA resins other than the denture base.
Oh, I think actually we did cover that one.
Cover it.
Here's one.
I missed the first few minutes. Did you mention the Varseo?
Hey, Miss Laura, we did not mention the Varseo. So on that particular printer, it is a 405 nanometer light processor. It has a pretty small build plate. It is good for for printing RPDs. Aside from that, it is also a closed system, so you do have to use Bagos resin with that printer. So I think that pretty much covered, and it is actually a pretty accurate printer. But again, just in my talking with other laboratories, the consensus on that printer is that it's great for RPDs, but not so much for mass production or anything crown and bridge.
Okay. Kurt asked if Whitmix offers leasing options.
So we personally do not lease. I have a fantastic gal that I use for all of my financing for all of my customers. So we would go ahead and get you set up on a lease with her, or you can actually go to your own finance institution if you would like.
And Craig asked if we would repeat the information on the approval.
Not really sure.
Not
approval of what?
Maybe the approval process for the ASIGA. I'm not really sure.
So Craig, if you were asking about the approval of Denka with ASIGA, we are in the process of getting that done. There's a lot of validation that has to go on in order for that printer to fall under their 510K.
Okay, that was the last of the questions as far as I can see. Yep, that's it. So I want to just remind you real quickly two things. One, that if you are a CDT, this program is worth an hour towards your recertification credit. So within a day or two, you're going to receive an email which will explain exactly how we're going to give you the credit. It does involve a very simple true-false test. So if you've been paying attention, I guess there's another question that came up. If you've been paying attention, we'll be sending you the certification that, rather their certificate that you can then turn in for credit with NVC. And the other thing is the webinar, as I mentioned a few minutes ago, is being recorded, and you will be able to access that on the Whitmix website in the webinar section within 1 to 2 days. Apparently, another question popped up by Kurt. Could you comment on the ASIGA purchase costs versus maintenance?
So on the ASIGA Max, the price point again is at $13,900. There are two consumables tied to this printer. One is the trays and the other is the resin. So the tray actually has a Teflon base, and when that UV light flashes and cures each layer, over time it begins to degrade and break down. So there is an RFID tag on that tray that the printer reads, and the printer is actually going to tell you when you are at capacity of use with that tray. With that being said, there are multiple sizes available: a 1, 2, 5, and 10 liter tray. Let's go with the 5 liter tray. You're not necessarily dumping 5 liters of resin in at once. You're simply filling it up as you go along. And that printer is going to let you know when you've ran 5 liters of resin through that tray. Now that's your insurance to make sure that the tray doesn't crack and you have resin leaking all over your printer. So again, you have two costs tied to the printer, the tray and the resin. Outside of that, it's a pretty maintenance-free printer. You do have to calibrate it. If you move the printer, you want to make sure it's sitting on a solid surface, not on a cart on wheels. Corey, can you think of any other maintenance?
Just keep it clean.
Yeah, just keep it clean and away from a window, no UV light. So I think that should answer your question, Kurt.
Well, it looks like we've come to the end of the questions and therefore the end of our webinar presentation. Sherry, thank you for doing a great job as always.
And thank you, Corey, for
and
chiming
Corey,
in.
of course, for helping out. And I just want to let you all know that we offer webinars every other Tuesday. Generally, there are some that are two-parters that may be in 2 consecutive Tuesdays. But if you're on our mailing list, you'll receive invitations. So we let you know ahead of time what's coming up. I want to thank you all for joining us today and invite you back. Look forward to seeing you at a future Whitmix webinar. Thanks again and have a great day.